This is Mr. Anderson for Math 121. This is the second part of Section 5, the common and natural logarithm, but this is the graphing section. So we're going to be taking a look at how do we graph, first of all, any problem with e in it, and then we're going to graph natural logs. So let's do a little bit of calc work here. When we do our calculator stuff, we got to make sure that we're plotting at least 5 good points, and we're also taking a look at the domain and range of each problem. So what I'm going to do is just take some time to write the function into the calc, and what I'm going to do here is plug in these 4 equations right away, all at the same time, and I can access that by hitting the second key and then the natural log key, and this first one's going to be x plus 3. The second equation is going to be 2 and then e raised to the x power. The third equation is going to be e raised to the x minus 2 power. And finally, we're going to have negative e raised to the negative x power. Now what I can do is go back to these little equal signs here and turn those on and off so I can select which graph I want to view at once. And my first graph is going to be this problem number 11 here. And so problem number 11, we are going to graph it here. Here's what it looks like on the screen, and here's what it looks like on our table. It's probably best to graph maybe 2 positive and 2 negative values here. So let's go and take a look at that. If we graph 2 positive and 2 negative values here, negative 2 will be about 3.1. Negative 1 would be about 3.3. 0 is 4. 1 is about 5.7, and 2 is off the grid a little bit at 10.3. Now this is my graph, and we could have seen that from the previous picture here. Now let's talk about domain and range. Domain are the x values and range are the y values. So my domain of this graph is going to be all real numbers, because this graph is going to negative infinity and will also go to positive infinity along the x. So this graph will go to negative infinity and positive infinity. But for my range are the y values. This graph goes no lower than 3. Since this graph was shifted 3 units up, this graph has an asymptote line, or basically a line that it cannot touch nor cross, at 3. So y will never be lower than 3 or never touch 3, but y will also go to positive infinity. So our range is going to be from 3 to infinity. Notice that I use parentheses here instead of a bracket because this line, this exponential line of base e, will never touch 3. Let's go now take a look at the next line. The next line is going to be, I'm going to turn that off and turn on the second one here. This is going to be doubling the speed. This has a start value of 2, so it's going to be our exponential graph with base e, but it's going to go up twice as fast, so the graph will quickly shoot off the screen, and we'll take a look at the plottable points here. And since 2 goes way off the screen here, maybe I'll plot from negative 3 to 1, since 2 just went off the screen. Alright, so let's go take a look and plot these in here. So my negative 3 is going to be at 0.09, which is about a tenth off the line, is really low. Negative 2 is going to be about 0.27 or a quarter. Negative 1 is going to be about 3/4 or 0.7. 0 is going to be at 2, and 1 is going to be at 5.4. So this is another graph that goes very quickly off the grid. Woo. And again, here's my domain and range. The domain are going to be my x values, and that's going to be real because this is going to go from negative x to positive x. It's going to go negative infinity on my x and positive infinity on my x because it goes continuously to the right. Now let's talk about our range. Our range, this has the asymptote line here at 0, and this will never cross 0, so we're going to go from 0 to positive infinity because the y values go from 0 to positive infinity on this graph. Alright, so let's go to the third picture here. Going to my y equals and turning off the second graph and turning on the third graph. This is going to shift the graph Sorry. This is going to shift the graph 2 units to the right. So let's go to my table here. My table, since I have, I can go to probably 4. I'm going to graph from 0 through 4 here. So 0 was, here, let me turn on my pen so I can draw on the screen. Okay, so my 0 is going to be about 13, so way down here. Whoa. There we go. And my 1 is going to be at a third, or 0.36. 2 is going to be at 1. 3 is going to be at 2.7. 4 is going to be at 7. So 7.4 actually. So there's my 5 points, and this graph, again, like the others, has a tail that goes all the way to negative infinity on my x, and positive infinity on my x, because this is going to go to the right. So my domain, like all the others here, are real. And my range is going to be from 0 to infinity again, because my lowest y value is 0, and my highest y value is infinity. So I think you're noticing that all of these exponential functions have this domain and range kind of property to them. So let's go to the final graph here, which is going to mix things up, because on this final graph, I am taking the negative, or another way of thinking about it, the reciprocal of this fraction, or this exponential right here. Let's go take a look at the picture. Alright, so you can see that it's now flipped over this, flipped over the x-axis and rotated a little bit. My little geometry senses are tingling here. So let's go and graph this here. Let's go see what I can get. Now it looks like I'm going to graph 2 negative and 2 positive. This will give me a good representation of what I've got here. So negative 2 is going to drop all the way down to negative 7.3, so that's about right there. Negative 1 is going to drop down to about negative 2.7, so it's about right there. 0, negative 1. 1 is negative 3, or negative 0.3, so it's a third of the way down. And then this is going to be about a tenth of the way down. So now what we have here is our... Oh, shoot! Ha! I really missed the mark there, because that line, that blue line, should not cross the x-axis here. Our domain is going to be real again, because this will go to negative infinity on my x, because it gets bigger and bigger. In this kind of sense, it really is going lower and lower, but this is getting wider and wider as it goes down. And this over here to the right will go to positive infinity. So since my x goes from negative infinity to positive infinity, my domain is real. Now my range, you'll notice that there is a dotted line here. It will not cross this 0. So it's going to go from 0 to negative infinity. Please make sure to write it like this, negative infinity comma 0. Because when we write this kind of notation for our domain and range, we go from low number to high number. So putting 0 comma negative infinity would be writing it incorrectly. Okay, so now we've done all of our exponentials. Now what we're going to do is go down to the bottom of our graph here and do all the natural logs. Now natural logs are inverses of the base e exponentials. So what you're going to see is a lot of domains and ranges inverted compared to what you saw up above. So keep that in mind, that when we have a problem, we are going to have the domain, when we have a problem and its inverse, the inverses x's and y's will be inverted, which makes the domain and range also inverted as well. Alright, now we'll have the natural log of x minus 3. Whoops, too many parentheses. And like I did before, I'm going to turn off the equations by hitting the Enter key on the equal sign. And so we'll take a look at the first problem here, problem 15. Let's go take a look at the natural log of x minus 1. So this shifts the graph down 1. So if I'm going to go to my table and plot these points, you'll notice that there are no negative values. So I'm just going to be picking 5 points, starting with 1. So what I'm going to do here is plot these points. Let's go to my screen here. Okay, so it looks like 1 on my x is negative 1 on my y. 2 on my x is negative 3.3. And then 3 on my x is now positive, so about a tenth. 4 on my x is now 0.4. And 5 on my x is 0.6. Alright, so now what I'm going to do is make my natural log curve. All right, so let's talk about domain and range. Now the domain are my x values that I can have, and this will not cross 0. This gets infinitely close to 0 but never touches it. And you'd have to change your x scale to show that it does get infinitely close to 0 but never touches it. And it will go to positive infinity on my x. So the domain is going to be from 0 to positive infinity. The range is going to be all real, because this line will go up forever and ever, so it will go to positive infinity on my range, and it will also go to negative infinity on my range as well. My y values will be positive and negative. Alright, let's take a look at the next problem here. Let's go to my second graph, which, whoops, hold on a second here. Alright, let's go to my second graph. This graph gets mixed up a little bit because of the negative there, and we can see that this got flipped around the x-axis again. Now let's take a look at the table and see how this looks out here. Okay, again, you're not going to have anything below 1, or actually, you're not going to have any numbers 0 or lower, because the domain of all of our logarithms and logs in general have to be greater than 0. So my table starts perfectly at 1, and 1 is going to be 0. So let's put a dot there. At 1 is 0. At 2 it's negative 0.69. At 3 it's a little bit beyond negative 1. At 4 it's about 1.3. And then 5 it's about 1.6. Alright, so what this is going to do, this is going to again get infinitely close but never touching the y-axis. Now obviously mine did, but you know, I'm not a computer, I can make a little mistake there. So my domain is going to be, again, there's not going to be any x value that's 0 or smaller, and it will go to all the positive values of x, so the domain is going to be from 0 to infinity. Now my range is going to be all real again, because we're going to have all my positive, this graph can be any positive y value. It can also essentially go down to any negative y value, so therefore all real. So if you start comparing the domains and ranges to the natural logs to the exponentials, it's kind of like what I said, where the domains and ranges are flip-flops or inverses of each other. Alright, now let's take a look at the last problem here. Let's go and turn that off and turn this on. And let's take a look at the graph. Now this is a little bit of a problem, because this graph is actually more than this. This graph should be, and depending on most of your calculators here, most of your calculators will not plot this, but there really should be the line continued, like so. It's just that your calculator doesn't put it in, but the graph does kind of curve and continue on, which is very important for your range, because some people just looking at the graph might think, oh no, the line stops there. But it doesn't. So let's go back to the table here and see what we got. So second graph here, there's my table. Now you'll notice my table doesn't start until 4, so I'm going to plot from 4 through, let's see, maybe 4 through 8 here. So let's go and put these on the screen here. Alright, so 4 is 0. Alright, and then 5 is 0.69. 6 is 1.10. 1.09 to be exact. Then we've got here, let's see, number 7 is 1.38 or 1.4, and number 8 is 1.6. So what we have here is this little hook. But again, as I said, this graph does kind of continue on, and this graph physically got shifted over 3. So there is kind of an asymptote line, which means that this line cannot touch nor cross it at 3 on my x, which means that our domain goes from 3 to infinity, because this graph goes from 3 to infinity. The range of this graph is all real, because yes, this goes down. Since this graph is completed, even though the calculator didn't show it, this graph is completed in the southern direction to negative infinity on my x, and it will eventually go to positive or negative infinity on my y, and then positive infinity on the y, because it's going to get bigger and bigger as it goes along. We're just only looking at this small part of it. Alright, well, thank you for watching. Email me if you have any questions.